Array of meeting time intervals, where intervals I equals start I, end I, return the minimum number of conference rooms required. So we're just looking for the number of overlapping intervals. Um, okay. This is just going to take me a second to figure out. I feel like this one's actually going to be pretty simple, but this one's just going to take a second to figure out the pattern. Okay. So, doing it in our head, we can say that this one you're going to need at least, okay, 2 conference rooms because this one's taking it up for all of them. And then you have 5 and 10. And so it's like, well, we can't fit in this, so we need our own room. And this one's 15, 20, so it can just wait for the second room. So you need 2. So, and then this is an example showing that they're not in order necessarily. We need it to be in pretty good time because the constraints are pretty wide. And we know that we're never going to be given some faulty inputs. So, this is a good problem. My first thought is this would be way easier if we sorted. By start time. I think it's way easier if we sort it by start time. Because then we can just go through the entire thing just by start time, and we say like, and we look at the active end times of all the meetings that have started. So we'd go through, so iterate through sorted intervals. If now we just say if we just keep track of the active end times. So then we basically say, okay, so if the start of next meeting comes after the end of an active meeting, comes after the end of an active meeting, then set that active end time to 0. Those to the update that active end time. And then the answer would just be the max length of the answer would just be the max length of uh oh wait, no. So here's the thing. We never actually delete active end times. Because if at the end of the day, like you have one, like let's see right here. So in this case, we would say, okay, we have 30, and then we try to fit in 5, but 5 doesn't fit. So now we have 10, and then 15 is greater than 10. So now that active time is 20. So now we just have 30 and 20, so we need 2. So at the end of the day, like, even if those, we never need to delete a time because we don't need to so that's good for the array thing because we never need to, well, that's good for the array values because we never actually need to costly delete the array values because it's like, it makes sense in my head. I'm trying to explain it. We never had to costly delete the array values because we never, like, that's the whole point of the array is that it's keeping track of which of the end times of meetings, but we only care about the end times of meetings when we're adding a new array, when we're adding a new interval. Let's just code it out. Like, I totally know this by now, but there's one condition that we also have to consider. Update active end time. Which one, if to fit? It doesn't matter because it's sorted by the start time. If we have 30 and 20 and we encounter 45, we know that all start times to come are going to be greater than 45. So if there's two options for 45, there will be two options for 50. Or there will be an option for 50. E.g., we have 30 and 20 as active start times. Try to, which one do we update to 45 from 45? Doesn't matter because, oh wait, no, it does matter. Wait, does it? I guess the end time could be much bigger than the start time. It doesn't matter because is there a way that that we can do it if it's sorted that um does it matter? So we have 30, let's see. We'll do it with really close values. So we have like 30 and 31 and then we have like 30. Well, these are just the end times, so we could be given like, oh, no, but it's only if we update it. Okay, if there's two options for 45, there will be at least one option for 46, regardless of which one you update. Okay, just had to go through that in my head. There we go. So that's what I'm saying. Okay, so if it doesn't matter which end time, so if two meeting rooms are available, it doesn't matter which one we take because if there are two, because since the next one starts later on, basically if the start time has two, yeah, I'm I'm overcomplicating it because I'm thinking of the numbers. Just simplify it. If the start time is greater than two active end times, that means that there's two empty meeting rooms, which means that any meeting that you can take either room. It doesn't matter. They're both empty. Doesn't matter. Okay. Here we go. Okay, so here we go. first we'll just put the first meeting room in there. We know that there's going to be at least one interval, so we'll just say um, active end times equals an array with intervals 0 and 1. So there's going to be at least, since there's going to be at least one interval, we need at least one end time. We're going to say return the length of the active end times at the end of the day. Then we're just going to append to it as we go on. So we'll say for intervals in intervals from 1 onwards. For interval in intervals from 1 onwards, because we've already used the first one. We'll say for is there a quick way of doing this? Do we want to go backwards through active end times? No, we don't, because it's not. Because you could have 30 and 20, but then you get like 21 to 40, so now it's 30 and 40. So maybe we we could do that, but that could just turn into O(n) time, because you could have a bunch of intervals that never line up. So every time you would be checking to see if you could fit that many rooms. But that would be too much. So you for every interval you'd be checking to see if it could fit into a room, and it would have to go through every single room. Bless you. So do we want to we don't want to we can't just say min and max. This is tricky because this could turn into O(n) time, which maybe is allowed because it's just 10,000. The intervals are relatively small. The constraints, it's not like 10 to the 5 or the 6. So we pass through every interval. I think this is the right strategy. I'm just trying to see where how we could optimize this one step of finding the interval that best suits it. Do we just sort it? No, sorting is m log n, which is longer. My thought was sort it. I guess the best thing that we could do would be to binary insert it into the list of active end times, or binary like update it, because that could be like log n. I'm just gonna say for end time in, let's just see if this works. For end time in active end times, we'll just say new for end time in active end times. Say start time new end time equals interval 0 and interval 1. We'll say if end time is less than if end time is less than, can they be equal? I'm gonna say it is inclusive if end time, and we'll see really quickly if that matters. if end time is less than start time, then we're going to say end time equals new end time. And then we can just break and then we can just put in a Boolean value like found room equals false. I'll say found room equals true. And then if we go through the entire array and we never find a room, then we say found room if not found room, then we append the end time. Active end times append new end time. That should work. No, it doesn't. Why doesn't it? Oh, because we never sorted it. We need to sort it. Intervals equals sorted. Intervals. Actually, should we say intervals dot sort? Key equals lambda x length or no, just x1 x is 0. So we're sorting it by the start time. There we go. Wow, I did a lambda function. Oh wait, those are just equal. We'll just say that. Oh, that's interesting. Let me use that test case. Okay, let's see. So we have the active end times is 5. So then we say, okay, let's try to find it. Found room is false, so we go through all the active end times, and 5 is less than that. So now we just update 5 to be 9. So now 5 should be 9. Why doesn't it update that? I'll just say for I in range length of active end times, end time equals active end times I, and active end times I equals new end time. Does that work? Okay, so there we go. So that was the difference between a for each loop and an index loop, I guess, is we were trying to be too cute and just update the value as is, but we were really just, I think, just getting a copy of the value, and we needed to access the array itself. I think that we could be even faster if we do a binary search and store it instead of going through the intervals every time, because as that gets big, like a binary insert is what I mean. What we would say is go through the active end times and basically for now that'd be funky. Because we'd use a binary search to go through it and see if we find one that was less than. Then we'd go through a binary search and see if we can find one that was find an end time which is less than or equal to the start time. But then we still had to, so then we'd update that value and then we'd do it again. So relatively faster for large values, but kind of clunky. This is fine, it seems, based on the constraints. All right, pretty happy with that.